Hi everyone, welcome to this very short video presentation of our Activity B, varietal performance analysis. And I'd like to present some progress that our team made over the last year. Quick reminder of what this activity is about. We're basically trying to estimate parameters of interest. So for breeders, those are usually genetic parameters using on-farm data. And this includes metric yield data that are collected in tricot trials, or some of them at least, but especially ranking data, which also includes harder to measure traits like overall appreciation, willingness to replant, marketability, and other traits. So these parameters of interest, to breeders, there's a couple that are probably interesting to mention. Of course, the genetic value or genotypic value of a variety, for example, yield, how good is a variety compared to others. Another interest is, of course, is the average value of this trait increasing over time as we have newer varieties, and that is realized genetic gain. In the context of tricot, it's also very important to talk about the expected response to selection on farm. So assuming that we're doing our selection on traits on station, we basically are interested in the realization of the genetic gain on farm as we apply the selection on station. And here, the genetic correlation between the traits selected on station and the ones expressed on farm, the RG that you see here, is an essential parameter we want to estimate. Another one that's important is the genetic variation that we can observe on farm, that is expressed on farm for the traits of interest. Now, this genetic correlation is calculated as follows and contains the heritability both on station and on farm as important components. So we'll get back to that. So the recent contributions. Briefly, we've been working on a tool for trial planning and design for tricot trials. We have been working on the methods for measuring and estimating this varietal performance on farm. Also, we've been working on the genotype by context interaction, so how well do varieties do in different contexts. And we've been trying to develop methods to predict the performance on farm based on trait values that we can measure on station or otherwise. Quickly, the sampling tool will help people to design the logistics of their tricot operation, calculate costs, and find efficient ways of distributing packages and generate the associated design. We'd like to test that with you and develop the functionality in discussion with others. The sample size calculations that we've made were in response to many very valid questions about how large should our tricot trials be, how many replicates per variety, how many farmers. And what we discovered is that there's a quite a simple answer to some of this that tells us that we need at least twice as many observations and twice as many replicates per variety when we're dealing with ranking data to have the same precision and statistical power as if we would use metric data for the same traits. There's also a minimum of around 10 to 20 replicates per genotype that will ensure that we can quantify our uncertainties correctly. We've also worked on the improvement of targeting for genotypes. So our target environment definitions by also including cost and profitability calculations that we can make by combining biophysical information, crop models, and socioeconomic variables. In the work on varietal performance itself, the estimates of genetic parameters, the genetic gain has now been estimated for a number of use cases in different crops, among them cassava, where we've observed that we can usually establish genetic gain for yield to have taken place on station, but the on-farm genetic yield tends to lag behind and is often not significant. So when we measure yield on farm, we don't find the same progress. Interestingly, though, there's some important rank-based traits like the willingness to replant or intention to replant that do show genetic progress. Other data that is important in this respect is that we've often find that the genetic variance or the variation for the traits of interest like yield are lower on farm and on station. And as we've seen, that can be part of the explanation of having lower on-farm genetic gain for those traits. Another lesson that we can draw from on-farm ranking data is that yield is not always the trait that most strongly determines if farmers want to replant a variety. There are several, in the case of cassava, several taste and consumer related traits that do predict quite well if farmers want to replant a variety. And that means that breeders might want to see how well, what the genetic correlation between the traits they select for and this on-farm trait might be. So we've developed a method to actually estimate heritability for ranking-based traits as well, as you can see here. And as we expect, heritabilities are lower for ranking-based traits due to lower precision. The usefulness of this is shown here, where we can not only calculate the genetic correlation between yields on farm and on station, which are actually very high, but can also show that these correlations are much lower when we relate this on-station yield that might be selected on to the on-farm replanting intention. And we find a much lower genetic correlation, which is relevant to know for breeders. We've also seen progress on the genotype by context in work that we've done, where we have now a statistical method for testing for genotype by context interactions in ranking data. We've developed very breeder-centric methods to quantify and study the structure of the genotype by context component in our data. So using ranking data and not metric data. Finally, we've made progress on a method that can not only predict on-farm performance as a function of varietal traits, but can also do so for different groups of rankers, like men and women, or maybe different environments, where we can test if there are different preferences that predict on-farm outcomes. And this method is superior to any existing method so far. So finally, what's next? Well, we'd like to start testing this prototype we've developed with you. We'd like to finalize and improve our variance component estimate methods using rankings, combine ranking and metric data in improved ways to get more valuable information out of on-farm data. Develop methods for multi-trait ranking analysis, where we can learn more about how traits relate to each other. Develop selection indices on station for predicting on-farm performance, and anything else that you might want to suggest. Thank you very much for listening.